CIET NCERT presents the audiobook Ganit Prakash, Textbook of Mathematics for Class 6.
Page number 242, Chapter number 10. The other side of zero. Integers. More and more numbers. Recall that the very first numbers we learnt about in the study of mathematics were the counting numbers 1, 2, 3, 4 and so on. Then we learnt that there are even more numbers. For example, there is the number 0 representing nothing, which comes before 1. The number 0 has a very important history in India and now in the world. For example, around the world we learn to write numbers in the Indian number system using the digits 0 to 9, allowing us to write numbers however large or however small using just these 10 digits. We then learned about more numbers that exist between the numbers 0, 1, 2, 3, 4, etc., such as 1 upon 2, 3 upon 2, and 13 upon 6. These are called fractions. But are there still more numbers? Well, 0 is an additional number that we didn't know about earlier, and it comes before 1 and is less than 1. Are there perhaps more numbers that come before 0 and are less than 0? Phrased another way, we have understood the number line. Here, there is a picture of a number ray with markings from 0 to 10. However, this is actually only a number ray in the language we have learnt earlier in geometry. This ray starts at 0 and goes forever to the right. Do there exist numbers to the left of 0? So that this number ray can be completed to the true number line? That is what we will investigate in this chapter. Page number 243. Can there be a number less than 0? Can you think of any ways to have less than 0 of something? 10.1. Bela's Building of Fun. Children flock to Bela's ice cream factory to see and taste her tasty ice cream. To make it even more fun for them, Bela purchased a multi-storied building and filled it with attractions. She named it Bela's Building of Fun. But this was no ordinary building. Observe that some of the floors in the Building of Fun are under the ground. What are the shops that you find on these floors? What is there on the ground floor? A lift is used to go up and down between the floors. It has two buttons, plus to go up and minus to go down. Can you spot the lift in the picture given? To go to the art center from the welcome hall, you must press the plus button twice. We say that the button press is plus plus or plus 2. To go down 2 floors, you must press the minus button twice, which we write as minus minus or minus 2. So, if you press plus 1, that is, if you press the plus button once, then you will go up 1 floor, and if you press minus 1, that is, if you press the minus button once, then you will go down 1 floor. Lift button presses and numbers. plus is written as +3. Minus is written as -4. What do you press to go 4 floors up? What do you press to go 3 floors down? Page number 244. Numbering the floors in the building of fun. Entry to the building of fun is at the ground floor level and is called the Welcome Hall. Starting from the ground floor, you can reach the food court by pressing +1 and can reach the art center by pressing +2. So, we can say that the food court is on floor +1 and that the art center is on floor +2. Starting from the ground floor, you must press -1 to reach the toy store. So, the toy store is on floor -1. Similarly, starting from the ground floor, you must press -2 to reach the video games shop. So, the video games shop is on floor -2. The ground floor is called floor 0. Can you think why? Number all the floors in the building of fun. Did you notice that +3 is the floor number of the bookstore, but it is also the number of floors you move when you press +3. Similarly, -3 is the floor number, but it is also the number of floors you go down when you press -3. That is, when you press minus minus minus. A number with a plus sign in front is called a positive number. A number with a minus sign in front is called a negative number. In the building of fun, the floors are numbered using the ground floor. Floor 0 as a reference or starting point. The floors above the ground floor are numbered with positive numbers. To get to them from the ground floor, one must press the plus button some number of times. The floors below the ground are numbered with negative numbers. To get to them from the ground floor, one must press the minus button some number of times. 0 is neither a positive nor a negative number. We do not put a plus or minus sign in front of it. Page number 245. Addition to keep track of movement. Start from the food court and press +2 in the lift. Where will you reach? We can describe this using an expression. Starting floor plus movement is equal to target floor. The starting floor is +1, that is food court, and the number of button presses is +2. Therefore, you reach the target floor +1 plus +2, that is equal to +3, that is bookstore. Figure it out. Question number 1. You start from floor +2 and press -3 in the lift. Where will you reach? Write an expression for this movement. Question number 2. Evaluate these expressions. You may think of them as starting floor plus movement by referring to the building of fun. A, +1 plus +4 is equal to dash. B, +4 plus +1 is equal to dash. C, +4 plus -3 is equal to dash. D, -1 plus +2 is equal to dash. E, -1 plus +1 is equal to dash. F, 0 plus +2 is equal to dash. G, 0 plus -2 is equal to dash. Question number 3. Starting from different floors, find the movements required to reach floor minus 5. For example, if I start at floor plus 2, I must press minus 7 to reach floor minus 5. The expression is within brackets plus 2 plus within brackets minus 7 is equal to minus 5. Find more such starting positions and the movements needed to reach floor minus 5 and write the expressions. Combining button presses is also called addition. Gurmeet was in the toy store and wanted to go down 2 floors. But by mistake, he pressed the plus button 2 times. He realized his mistake and quickly pressed the minus button 3 times. How many floors below or above the toy store will Gurmeet reach? Gurmeet will go 1 floor down. We can show the movement resulting from combining button presses as an expression within brackets plus 2 plus within brackets minus 3 is equal to minus 1. Page number 246. Figure it out. Evaluate these expressions by thinking of them as the resulting movement of combining button presses. A within brackets 1 plus within brackets 4 is equal to dash. B within brackets plus 4 plus within brackets plus 1 is equal to dash. C within brackets plus 4 plus within brackets minus 3 plus within brackets minus 2 is equal to dash. D within brackets minus 1 plus within brackets plus 2 plus within brackets minus 3 is equal to dash. Back to 0. On the ground floor, Basant is in a very hurry and by mistake he presses plus 3. What can he do to cancel it and stay on the ground floor? He can cancel it by pressing minus 3, that is within brackets plus 3 plus within brackets minus 3 is equal to 0. We call minus 3 the inverse of plus 3. Similarly, the inverse of minus 3 is plus 3. If Basant now presses plus 4 and then presses minus 4 in the lift, where will he reach? Here is another way to think of the concept of inverse. If you are at floor plus 4 and you press its inverse minus 4, then you are back to 0. The ground floor. If you are at floor minus 2 and press its inverse plus 2, then you go to minus 2 plus within brackets plus 2 is equal to 0. Again the ground floor. Write the inverses of these numbers. Plus 4, comma minus 4, comma minus 3, comma 0, comma plus 2, comma minus 1. Connect the inverses by drawing lines. We are given some numbers here as plus 5, minus 7, minus 8, plus 9. And in another row we have minus 9, plus 8, minus 5 and plus 7. We need to connect the inverses by drawing the lines. Comparing numbers using floors. Who is on the lowest floor? First, Jay is in the art center, so he is on floor plus 2. Second, Asin is in the sports center, so she is on floor dash. Third, Binu is in the cinema center, so she is on floor dash. Fourth, Aman is in the toy center, so he is on floor dash. Page number 247. Floor plus 3 is lower than floor plus 4. So we write plus 3 is less than plus 4. We also write plus 4 is greater than plus 3. Should we write minus 3 less than minus 4 or minus 4 less than minus 3? Floor minus 4 is lower than floor minus 3. So, minus 4 less than minus 3. Is it also correct to write minus 3 is greater than minus 4? Figure it out. Question number 1. Compare the following numbers using the building of 1 and fill in the boxes with less than or greater than symbol. A. Minus 2 blank plus 5. B. Minus 5 blank plus 4. C. Minus 5 blank minus 3. D. Plus 6 blank minus 6. E. 0 blank minus 4. F. 0 blank plus 4. Notice that all negative number floors are below floor 0. So, all negative numbers are less than 0. All the positive number floors are above floor 0. So, all positive numbers are greater than 0. Question number 2. Imagine the building of 1 with more floors. Compare the numbers and fill in the boxes with less than or greater than. A. Minus 10 blank minus 12. B. Plus 17 blank minus 10. C. 0 blank minus 20. D. Plus 9 blank minus 9. E. Minus 25 blank minus 7. F. Plus 15 blank minus 17. Question number 3. If floor A is equal to minus 12, floor D is equal to minus 1 and floor E is equal to plus 1 in the building shown on the right as a line. Find the numbers of floor B, C, F, G and H. Here on the right side of the page, we have a number line with markings on it written as A minus 12. Then we have markings as B, C, D with minus 1. Then we have 0. Then E with plus 1. F, G and H. Question number 4. Mark the following floors of the building given on the right. A. Minus 7. B. Minus 4. C. Plus 3. D. Minus 10. Subtraction to find which button to press. In earlier classes, we understood the meaning of subtraction as take away. For example, there are 10 books on the shelf. I take away 4 books. How many are left on the shelf? We can express the answer using subtraction. 10 minus 4 is equal to 6, or 10 take away 4 is 6. Page number 248. You may also be familiar with another meaning of subtraction, which is related to comparison or making quantities equal. For example, consider this situation. I have 10 rupees with me and my sister has 6 rupees. Now, I can ask the question, how much more money should my sister get in order to have the same amount as me? We can write this in two ways. 6 plus dash is equal to 10. or 10 minus 6 is equal to dash. Here we see the connection between finding the missing number to be added and subtraction. For subtraction of positive and negative numbers, we will use this meaning of subtraction as making equal or finding the missing number to be added. Evaluate 15 minus 5, 100 minus 10, and 74 minus 34 from this perspective. Teacher's note: in general, when there are two unequal quantities, subtraction can indicate the change needed to make the quantities equal. Subtraction shows how much the starting quantity should change in order to become the target quantity. In the context of different flow levels, what is the change required to reach the target floor from the starting floor? Notice that the change needed may be positive for an increase or negative for a decrease. Your starting floor is the art center and your target floor is the sports center. What should be your button press? You need to go 3 floors up, so you should press plus 3. We can write this as an expression using subtraction. Target floor minus starting floor is equal to movement needed. In the above example, the starting floor is plus 2, art center, and the target floor is plus 5. The button press to get to plus 5 from plus 2 is plus 3. Therefore, within brackets plus 5 minus within brackets plus 2 is equal to plus 3. Page number 249. Explanation. Recall the connection between addition and subtraction. For 3 plus dash is equal to 5. We can find the missing number using subtraction. 5 minus 3 is equal to 2. That is, subtraction is the same as finding the missing number to be added. We know that starting floor plus movement needed is equal to target floor. If the movement needed is to be found, then starting floor plus dash is equal to target floor. So, target floor minus starting floor is equal to dash. That is equal to movement needed. More examples. A. If the target floor is minus 1 and starting floor is minus 2, what button should you press? You need to go one floor up, so you should press plus 1. Expression within brackets minus 1 minus within brackets minus 2 is equal to within brackets plus 1. B. If the target floor is minus 1 and starting floor is plus 3, what button should you press? You need to go 4 floors down, so you should press minus 4. Expression within brackets minus 1 minus within brackets plus 3 is equal to within brackets minus 4. C. If the target floor is plus 2 and starting floor is minus 2, what button should you press? You need to go 4 floors up, so you should press plus 4. Expression within brackets plus 2 minus within brackets minus 2 is equal to within brackets plus 4. Figure it out. Complete these expressions. You may think of them as finding the movement needed to reach the target floor from the starting floor. A. Within brackets 1 minus within brackets 4 is equal to dash. B. 0 minus within brackets 2 is equal to dash. C. Within brackets plus 4 minus within brackets plus 1 is equal to dash. D within brackets 0 minus within brackets minus 2 is equal to dash. E within brackets plus 4 minus within brackets minus 3 is equal to dash. F within brackets minus 4 minus within brackets minus 3 is equal to dash. G within brackets minus 1 minus within brackets plus 2 is equal to dash. H within brackets minus 2 minus within brackets minus 2 is equal to dash. I within brackets minus 1 minus within brackets plus 1 is equal to dash. J within brackets plus 3 minus within brackets minus 3 is equal to dash. Page number 250. Adding and subtracting large numbers. The picture given here is a mine, a place where minerals are extracted by digging into the rock. The truck is at the ground level, but the minerals are present both above and below the ground level. There is a fast moving lift which moves up and down in a mine shaft carrying people and ore. Some of the levels are marked in the given picture. The ground level is marked 0. Levels above the ground are marked by positive numbers and levels below the ground are marked by negative numbers. The number indicates how many meters above or below the ground level it is. In the mine, just like in the building of fun, starting level plus movement is equal to target level. We have a picture of a mine giving different levels and markings as minus 175 meters, then minus 125 meters, minus 80 meters, then minus 50 meters, 0 meters, then 40 meters, plus 100 meters, plus 125 meters, and plus 180 meters. In the mine, just like in the building of fun, starting level plus movement is equal to target level. For example, within brackets plus 40 plus within brackets plus 60 is equal to plus 100. Within brackets minus 90 plus within brackets minus 55 is equal to minus 145. Target level minus starting level is equal to movement needed. For example, within brackets minus 40 minus within brackets minus 50 is equal to plus 90. Within brackets minus 90 minus within brackets plus 40 is equal to minus 130. How many negative numbers are there? Bela's building of fun had only 6 floors above and 5 floors below. That is numbers minus 5 to plus 6. In the mine given here, we have numbers from minus 200 to plus 180. But we can imagine larger buildings or mine shafts. Just as positive numbers plus 1, plus 2, plus 3 and so on keep going up without an end. Similarly, negative numbers minus 1, minus 2, minus 3 and so on keep going down. Positive and negative numbers with 0 are called integers. They go both ways from 0. Minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4 and so on. Page number 251. Figure it out. Complete these expressions. A within brackets plus 40 plus dash is equal to plus 200. B. Within brackets plus 40 plus dash is equal to minus 200. C. Within brackets minus 50 plus dash is equal to plus 200. D. Within brackets minus 50 plus dash is equal to minus 200. E. Within brackets minus 200 minus within brackets minus 40 is equal to dash. F. Within brackets plus 200 minus within brackets plus 40 is equal to dash. G. Within brackets minus 200 minus within brackets plus 40 is equal to dash. Check your answers by thinking about the movement in the mind shaft, adding, subtracting, and comparing any numbers. To add and subtract even larger integers, we can imagine even larger lifts. In fact, we can imagine a lift that can extend forever upwards and forever downwards, starting from level 0. There does not even have to be any building or mine around, just an infinite lift. We can use this imagination to add and subtract any integers we like. For example, suppose we want to carry out the subtraction plus 2000 minus within brackets minus 200. We can imagine a lift with 2000 levels above the ground and 200 below the ground. Recall that target level minus starting level is equal to movement needed. To go from the starting floor minus 200 to the target floor plus 2000, we must press plus 2200 within brackets plus 200 to get to 0, and then plus 2000 more after that to get to plus 2200. Therefore, within brackets plus 2000 minus within brackets minus 200 is equal to plus 2200. Notice that within brackets plus 2000 plus within brackets plus 200 is also plus 2200. Try evaluating the following expressions by similarly drawing or imagining a suitable lift. A. Minus 125 plus within brackets minus 30. B. Plus 105 minus within brackets minus 55. C. Plus 105 plus within brackets plus 55. D. Plus 80 minus within brackets minus 150. E. Plus 80 plus within brackets plus 150. F. Minus 99 minus within brackets minus 200. G. Minus 99 plus within brackets plus 200. H. Plus 1500 minus within brackets minus 1500. Page number 252. In the given example, we saw that plus 2000 minus within brackets minus 200 is equal to plus 2000 plus within brackets plus 200, that is equal to plus 2200. In other words, subtracting a negative number is the same as adding the corresponding positive number. That is, we can replace subtraction of a negative number by addition of a positive number. In the other exercises that you did above, did you notice that subtracting a negative number was the same as adding the corresponding positive number? Take a look at the infinite lift above. Does it remind you of a number line? In what ways? back to the number line. The infinite lift we saw above looked very much like a number line, didn't it? In fact, if we rotate it by 90 degrees, it basically becomes a number line. It also tells us how to complete the number array to the number line, answering the question that we had asked at the beginning of the chapter. To the left of 0 are the negative numbers -1, -2, -3 and so on. Usually, we drop the plus sign on positive numbers and simply write them as 1, 2, 3 and so on. Here a picture of a number line is given on which we have markings -10, -9, -8, -7, -6, -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Instead of traveling along the number line using a lift, we can simply imagine walking on it. To the right is the positive forward direction and to the left is the negative backward direction. Smaller numbers are now to the left of bigger numbers and bigger numbers are to the right of smaller numbers. So 2 is less than 5, -3 is less than 2 and -5 is less than -3. If from 5 you wish to go over to 9, how far must you travel along the number line? On a number line, we can see a picture here with markings 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The movement is shown from 5 to 6 with an arrow, 6 to 7, then from 7 to 8 and from 8 to 9. So we are reaching from 5 to 9 here. Page number 253. You must travel 4 steps. That is why 5 plus 4 is equal to 9. Remember, starting number plus movement is equal to target number. The corresponding subtraction statement is 9 minus 5 is equal to 4. Remember, target number minus starting number is equal to movement needed. Now, from 9, if you wish to go to 3, how much must you travel along the number line? We have a number line here on which we have markings from 0 to 10 and there are markings starting from 9. 9, we are coming back to 8, from 8 towards 9, 9 to 6, 6 to 5, 5 to 4 and 4 to 3. So from 9 we are reaching to 3. You must move 6 steps backwards, that is, you must move -6. Hence, we write 9 plus within brackets -6 is equal to 3. Remember again, starting number plus movement is equal to target number. The corresponding subtraction statement is 3 minus 9 is equal to -6. Remember again, target number minus starting number is equal to movement needed. Now from 3, if you wish to go to -2, how far must you travel? Here we have a picture of a number line in which we are moving from 3 to -2. From 3 you go to 2, from 2 we move to 1, from 1 to 0, 0 to -1 and from -1 to -2. You must travel -5 steps, that is 5 steps backward. Thus 3 plus within brackets -5 is equal to -2. The corresponding subtraction statement is -2 minus 3 is equal to minus 5. Figure it out. We are given a picture of a number line with markings minus 10, minus 9, minus 8 to plus 10. Question number 1. Mark 3 positive numbers and 3 negative numbers on the number line given here. Question number 2. Write down the 3 marked negative numbers in the following boxes. We are provided with 3 boxes for the numbers to be written here. Page number 254. Question number 3. Is 2 greater than minus 3? Why? Is minus 2 less than 3? Why? Question number 4. What are A. minus 5 plus 0, B. 7 plus within brackets minus 7, C. minus 10 plus 20, D. 10 minus 20, E. 7 minus within brackets minus 7, F. minus 8 minus within brackets minus 10. Using the unmarked number line to add and subtract. Just as you can do additions, subtractions, and comparisons with small numbers using the number line given here, you can also do them with large numbers by imagining an infinite number line or drawing an unmarked number line as given here. We have picture of a number line with 0 marked at the center and 2 arrows on both the sides. This line shows only the position of 0. Other numbers are not marked. It can be convenient to use this unmarked number line to add and subtract integers. You can represent or simply imagine the scale of the number line and the positions of numbers on it. For example, this unmarked number line within brackets UNL represents the addition problem 85 plus within brackets minus 60 is equal to dash. Here we have a picture of a number line with marking 0 and plus 25 and plus 85. There's a movement from 85 to plus 25 by moving minus 60. We then can visualize that 85 plus within brackets minus 60 is equal to 25. The following UNL shows a subtraction problem, which can also be written as a missing addend problem. Within brackets minus 100 minus within brackets plus 250 is equal to dash, or 250 plus dash is equal to minus 100. Here we have a picture of a number line with markings 0 and plus 250 towards the right, and towards the left we have minus 100. The arrow is from plus 250 towards minus 100. We can then visualize that how much is to be subtracted to get minus 350 in this problem. In this way, you can carry out addition and subtraction problems with positive and negative numbers on paper or in your head using an unmarked number line. Page number 255. Use unmarked number lines to evaluate these expressions. A. minus 125 plus within brackets minus 30 is equal to dash. B. plus 105 minus within brackets minus 55 is equal to dash. C. plus 80 minus within brackets minus 150 is equal to dash. D minus 99 minus within brackets minus 200 is equal to dash. Here we have a picture of a number line with marking 0 and plus 2 towards right and minus 3 towards left, with the arrow showing from 2 to minus 3 and a marking minus 5 on it. Converting subtraction to addition and addition to subtraction. Recall that target floor minus starting floor is equal to movement needed, or target floor is equal to starting floor plus movement needed. If we start at 2 and wish to go to minus 3, what is the movement needed? First method. By exploring the number line, we find that we need to move minus 5, that is 5 in the backward direction. Therefore, minus 3 minus 2 is equal to minus 5. The movement needed is minus 5. Second method, break the journey from 2 to minus 3 into two parts. A. From 2 to 0. The movement is 0 minus 2 is equal to minus 2. B. From 0 to minus 3. The movement is minus 3 minus 0 is equal to minus 3. The total movement is the sum of the two movements. Minus 3 plus within brackets minus 2 is equal to minus 5. We have two colored expressions here. There is no subtraction in the second one. In this way, we can always convert subtraction to addition. The number that is being subtracted can be replaced by its inverse and then added instead. Similarly, a number that is being added can be replaced by its inverse and then subtracted. In this way, we can always convert addition to subtraction. Repeat. In this way, we can also always convert addition to subtraction. Examples. A. Within brackets plus 7 minus within brackets plus 5 is equal to within brackets plus 7 plus within brackets minus 5. B. Within brackets minus 3 minus within brackets plus 8 is equal to within brackets minus 3 plus within brackets minus 8. C. Within brackets plus 8 minus within brackets minus 2 is equal to within brackets plus 8 plus within brackets plus 2. D. Within brackets plus 6 minus within brackets minus 9 is equal to within brackets plus 6 plus within brackets plus 9. Page number 256. 10.2. The token model. Using tokens for addition. In Bela's building of fun, the lift attendant is bored. To entertain himself, he keeps a box containing lots of positive, red, and negative black tokens. Each time he presses the plus button, he takes a positive token from the box and puts it in his pocket. Similarly, each time he presses the minus button, he takes a negative token and puts it in his pocket. He starts on the ground floor, that is floor 0, with an empty pocket. After 1 hour, he checks his pocket and finds plus 5 positive and 3 negative tokens. On which floor is he now? He must have pressed plus 5 times and minus 3 times and within brackets plus 5 plus within brackets minus 3 is equal to plus 2. So he is at floor plus 2 now. Here is another way to do the calculation. A positive token and a negative token cancel each other because the value of this pair of tokens together is 0. These two tokens in his pocket meant that he pressed plus once and minus once respectively, and these cancel each other. We say that a positive and a negative token makes a zero pair. When you remove all the zero pairs, you are left with two positive tokens. So, within brackets plus 5 plus within brackets minus 3 is equal to plus 2. We can perform any such addition using tokens. We can find a picture of the tokens with red and green color here, and they are represented by cancelling positive and negative tokens. Example, add plus 5 and minus 8. Here we can find a picture with 5 green tokens and 8 red tokens, and 5 red and green tokens cancel out each other. So we are left with minus 3 red tokens. Page number 257. From the picture, we find that we can remove 5 zero pairs and we are then left with minus 3. Therefore, within brackets plus 5 plus within brackets minus 8 is equal to minus 3. Figure it out. First question. Complete the additions using tokens. A. Within brackets plus 6 plus within brackets plus 4. B. Within brackets minus 3 plus within brackets minus 2. C. Within brackets plus 5 plus within brackets minus 7. D. Within brackets minus 2 plus within brackets plus 6. Question number 2. Cancel the zero pairs in the following two sets of tokens. On what floor is the lift attendant in each case? What is the corresponding addition statement in each case? A. There are 3 green buttons and 5 red tokens. B. We have here 6 green tokens and 3 red minus tokens. Using tokens for subtraction. We have explored how to perform addition of integers with positive tokens and negative tokens. We can also perform subtraction using tokens. Example, let us subtract within brackets plus 5 minus within brackets plus 4. This is easy to do. From 5 positives, take away 4 positives to see the result. We have a picture here with 5 green plus tokens, and we cancel out 4 plus tokens and we are left with only plus 1 red token. Example, let us subtract within brackets minus 7 minus within brackets minus 5. We have here minus 7 red tokens and we are subtracting minus 5 red tokens and we are left with only 2 red tokens which represent minus 2. Is within brackets minus 7 minus within brackets minus 5 the same as within brackets minus 7 plus within brackets plus 5? Example, let us subtract within brackets plus 5 minus within brackets plus 6. Put down 5 positives. But there are not enough tokens to take out 6 positives. We have here picture of 5 green plus tokens. Page number 258. To get around this issue, we can put out an extra zero pair, that is a positive and a negative, knowing that this does not change the value of the set of tokens. Now, we can take out 6 positives. Observe what is left. We conclude that within brackets plus 5 minus within brackets plus 6 is equal to minus 1. Here we have a picture of 6 green plus tokens and 1 red with a minus sign token here, and we can see that if we take plus 5 green tokens and subtract plus 6, we are left with only with minus 1, that is 1 red token. Figure it out. First one, evaluate the following differences using tokens. Check that you get the same result as with other methods you know now. A within brackets plus 10 minus within brackets plus 7. B within brackets minus 8 minus within brackets minus 4. C within brackets minus 9 minus within brackets minus 4. D within brackets plus 9 minus within brackets plus 12. E within brackets minus 5 minus within brackets minus 7. F within brackets minus 2 minus within brackets minus 6. Question number 2. Complete the subtractions. A within brackets minus 5 minus within brackets minus 7. B within brackets plus 10 minus within brackets plus 13. C within brackets minus 7 minus within brackets minus 9. D within brackets plus 3 minus within brackets plus 8. E within brackets minus 2 minus within brackets minus 7. F within brackets plus 3 minus within brackets plus 15. Example, plus 4 minus within brackets minus 6. We have here plus 4 green tokens. In the picture, we have to take out 6 negatives from these. But there are not enough negatives. This is not a problem. We add some zero pairs as this does not change the value of the set of tokens. This is not a problem. We add some zero pairs as this does not change the value of the set of tokens. But how many zero pairs? We have to take away 6 negatives, so we put down 6 zero pairs. We have 10 green tokens here and 6 red tokens here. Now we can take away 6 negatives. Therefore, we have plus 4 minus within brackets minus 6 is equal to plus 10. We find in the picture that out of 10 plus tokens, we have removed 6 red tokens. So, we are left with plus 10. Page number 259. Figure it out. Question number 1. Try to subtract minus 3 minus within brackets plus 5. How many zero pairs will you have to put in? What is the result? Question number 2. Evaluate the following using tokens. A within brackets minus 3 minus within brackets plus 10. B within brackets plus 8 minus within brackets minus 7. C within brackets minus 5 minus within brackets plus 9. D within brackets minus 9 minus within brackets plus 10. E within brackets plus 6 minus within brackets minus 4. F within brackets minus 2 minus within brackets plus 7. 10.3 Integers in other places, credits and debits. Suppose you open a bank account at your local bank with the 100 rupees that you had been saving over the last month. Your bank balance therefore starts at 100 rupees. Then you make 60 rupees at your job the next day and you deposit it in your account. This is reflected in your bank passbook as a credit. Your new bank balance is dash. The next day you pay your electric bill of 30 rupees using your bank account. This is reflected in your bank passbook as a debit. Your bank balance is now dash. The next day, you make a major purchase for your business of 150 rupees. Again, this is reflected as a debit. What is your bank balance now? Dash. Is this possible? Yes. Some banks do allow your account balance to become negative temporarily. Some banks also charge you an additional amount if your bank balance becomes negative in the form of interest or a fee. Your strategic large purchase the previous day allows you to make 200 rupees at your business the next day. Page number 260. What is your balance now? Dash. You can think of credits as positive numbers and debits as negative numbers. The total of all your credits, that is positive numbers, and debits, that is negative numbers, is your total bank account balance. This can be positive or negative. In general, it is better to try to keep a positive balance in your bank account. Figure it out. Question number 1. Suppose you start with 0 rupees in your bank account and then you have credits of 30 rupees, 40 rupees and 50 rupees and debits of 40 rupees, 50 rupees and 60 rupees. What is your bank account balance now? Question number 2. Suppose you start with 0 rupees in your bank account and then you have debits of 1 rupee, 2 rupees, 4 rupees, 8 rupees, 16 rupees, 32 rupees, 64 rupees and 128 rupees and then a single credit of 256 rupees. What is your bank account balance now? Question number 3. Why is it generally better to try and maintain a positive balance in your bank account? What are circumstances under which it may be worthwhile to temporarily have a negative balance? As you can observe, positive and negative numbers along with zero are extremely useful in the world of banking and accounting. Geographical cross sections. We measure the height of geographical features like mountains, plateaus, and deserts from sea level. The height at sea level is 0 meters. Heights above sea level are represented using positive numbers and heights below sea level are represented using negative numbers. Page number 261. Figure it out. Question number 1. Looking at the geographical cross section, fill in the respective heights. A dash, B dash, C dash, D dash, E dash, F dash, G dash. Here we are given a picture which gives you an geographical cross section representing sea level at 0 and minus 500, minus 1000, minus 1500 below sea level, plus 500, plus 1000, plus 1500 heights above sea level in meters. Teacher's note. Ask what a geographical cross section is by showing the figure on this page. It is like imagining a vertical slice taken out at some location on the earth. This is what would be seen from a side view. Discuss the notion of sea level for measuring heights and depths in geography. Question number 2. What is the highest point in this geographical cross section? What is the lowest point? Question number 3. Can you write the points A, B, etc., G in a sequence of decreasing order of heights? Can you write the points in a sequence of increasing order of heights? Question number 4. What is the highest point above sea level on earth? What is its height? Question number 5. What is the lowest point with respect to sea level on land or on the ocean floor? What is its height? This height should be negative. Page number 262. Temperature. During summer time, you would have heard in the news that there is a heat wave. What do you think will be the temperature during the summer when you feel very hot? In the winter, we have cooler or colder temperatures. What has been the maximum temperature during the summer and the minimum temperature during the winter last year in your area? Find out. When we measure temperature, we use Celsius as the unit of measure, degree Celsius. The temperatures given here are indicating 40 degrees Celsius and 15 degrees Celsius temperatures. We can see the thermometers in which there are markings from -20 to 100 as -20, -10, 0, 10, 20, 30, 40, 50, 60, 70, 80, 90 and 100. They are in degrees Celsius. We can see the mercury level till 40 degrees Celsius in the first thermometer, and in the next thermometer we have till 15 degree Celsius. Figure it out. Question number 1. Do you know that there are some places in India where temperatures can go below 0 degrees Celsius? Find out the places in India where temperatures sometimes go below 0 degrees Celsius. What is common among these places? Why does it become colder there and not in other places? Question number 2. Leh in Ladakh gets very cold during the winter. Here, there is a table of temperature readings taken during different times of the day and night in Leh on a day in November. Match the temperature with the appropriate time of the day and night. We have two columns here. In first column, temperatures given are 14 degrees Celsius, 8 degrees Celsius, -2 degrees Celsius and -4 degrees Celsius. You need to match with the values of time given in another column as 2 a.m., 11 p.m., 2 p.m. and 11 a.m. Page number 263. Teacher's note. Talk about thermometers and how they are used to measure temperature. Bring a laboratory thermometer to the class and measure the temperature of hot water and cold water. Point out to the children that there are markings in the thermometer that are less than 0 degrees Celsius. Have a discussion on what 0 degrees Celsius indicates, namely the freezing point of water. 10.4 Explorations with integers. A hollow integer grid. There is something special about the numbers in these two grids. Here in the picture, we are provided with 3 by 3 grids, 2 in number. There are some numbers represented in the grids as -1, -1, 2 in the third row. We have integers 4, -1, -3 in the first row, -1, -1, 2 in the third row. In the second row, we have -3 and 1 with a blank in the middle. In the second grid, we have numbers 5, -3, -5 in the first row, -8, -2, 7 in the third row. In the second row, we have 0, -5 with a blank in between. There is something special about the numbers in these two grids. Let us explore what that is. Top row 4 plus within brackets -1 plus within brackets -3 is equal to 0. Bottom row within brackets -1 plus within brackets -1 plus 2 is equal to 0. Left column 4 plus within brackets minus 3 plus within brackets minus 1 is equal to 0. Right column within brackets minus 3 plus 1 plus 2 is equal to 0. Similarly, for the second grid in the top row, we have 5 plus within brackets minus 3 plus within brackets minus 5 is equal to dash. Bottom row, we have minus 8 plus minus 2 within brackets plus 7 is equal to dash. Left column, 5 plus 0 plus within brackets minus 8 is equal to dash. Right column, within brackets minus 5 plus within brackets minus 5 plus 7 is equal to dash. In each grid, the numbers in each of the two rows, that is the top row and the bottom row, and the numbers in each of the two columns, that is the leftmost column and the rightmost column, add up to give the same number. We shall call this sum as the border sum. The border sum of the first grid is 0. Figure it out. Question number 1. Do the calculations for the second grid above and find the border sum. Page number 264. Question number 2. Complete the grids to make the required border sum. We have 3 by 3 grids here. In the first grid, we have minus 10 as the first number in the first box, and in the second row we have minus 5 in the third column, middle row, in the third row, first column, and the border sum is plus 4. For the second grid, we have integers as 6, 8 and blank. In the second row, we have 2 blanks and minus 5, and in the third row we have blank, minus 2, again blank. The border sum is minus 2 in this case. In the third grid we have 7 in the first row, and in the second row, third column, we have minus 5, and all other boxes are blank. The border sum is minus 4. Question number 3. For the last grid given here, find more than one way of filling the numbers to get border sum minus 4. Question number 4. Which other grids can be filled in multiple ways? What could be the reason? Question number 5. Make a border integer square puzzle and challenge your classmates. An amazing grid of numbers. Given here is a grid having some numbers. Follow the steps as given until no number is left. We have 4 by 4 grid here with the integers written as 3, 4, 0, 9 in the first row, minus 2, minus 1, minus 5, 4 in the second row, 1, 2, minus 2, 7 in the third row, minus 7, minus 6, minus 10, minus 1 in the fourth row. We have a flow chart also to follow the instructions. First one, circle any number, then strike out the row and column of the chosen number. Then circle any unstruck number. Again, go back to the second step, strike out the row and column of the chosen number. When there are no more unstruck numbers, stop. Add the circled numbers. In the example given, the circled numbers are minus 1, 9, minus 7, minus 2. If you add them, you get minus 1. This process is explained in the grids here. We have 4 respective grids following the instructions given, and you can observe that in the example the circle numbers add up to minus 1. Page number 265. Figure it out. Question number 1. Try afresh. Choose different numbers this time. What sum did you get? Was it different from the first time? Try a few more times. Question number 2. Play the same game with the grids given here. What answer did you get? Here we have 4 by 4 grids. In the first grid, the integers written in the first row are 7, 10, 13, 16. In the second row, -2, 1, 4, 7. In the third row, -11, -8, -5, -2. In the fourth row, -20, -7, -14 and -11. In the second 4 by 4 grid, we have the integers as -11, -10, -9, -8 in the first row, -7, -6, -5, -4 in the second row, -3, -2, -1, 0 in the third row, and 1, 2, 3, 4 in the fourth row. Question number 3. What could be so special about these grids? Is the magic in the numbers or the way they are arranged or both? Can you make more such grids? Figure it out. Question number 1. Write all the integers between the given pairs in increasing order. A. 0 and -7. B. -4 and 4. C. -8 and -15. D. -30 and -23. Question number 2. Give 3 numbers such that their sum is -8. Question number 3. There are 2 dice whose faces have these numbers: -1, 2, -3, 4, -5 and 6. The smallest possible sum upon rolling these dice is -10. That is equal to within brackets -5 plus within brackets -5. And the largest possible sum is 12. That is equal to 6 plus 6. Some numbers between -10 and +12 are not possible to get by adding numbers on these 2 dice. Find those numbers. Question number 4. Solve these. We have 2 rows and 4 columns here. In the first row, first column, we have 8 minus 13. First row, second column, we have within brackets -8 minus within brackets 13. First row, third column, we are given within brackets -13 minus within brackets -8. First row, fourth column, we have within brackets -13 plus within brackets -8. Second row and first column, we have 8 plus within brackets -13. In the second row, second column, we have within brackets -8 minus within brackets -13. In the second row and third column, we have 13 minus 8. In the second row and fourth column, we have 13 minus within brackets -8. Question number 5. Find the years below. A. From the present year, which year was it 150 years ago? Dash. B. From the present year, which year was it 2200 years ago? Dash. Hint provided here is, recall that there are no year 0. Page number 266. C. What will be the year 320 years after 680 BCE? Dash. Question number 6. Complete the following sequences. A. Within brackets -40, comma, within brackets -34, comma, within brackets -28, comma, within brackets -22, dash, comma, dash, comma, dash. B. 3, 4, 2, 5, 1, 6, 0, 7, dash, dash, dash. C dash, dash, 12, 6, 1, within brackets -3, within brackets -6, dash, dash, dash. Question number 7. Here are 6 integer cards. Within brackets +1, within brackets +7, within brackets +18, within brackets -5, within brackets -2, within brackets -9. You can pick any of these and make an expression using additions and subtractions. Here is an expression within brackets +18 plus within brackets +1 minus within brackets +7 minus within brackets -2, which gives a value within brackets +14. Now pick cards and make an expression such that its value is closer to within brackets -30. Question number 8. The sum of two positive integers is always positive, but a positive integer minus positive integer can be positive or negative. What about A, positive minus negative, B, positive plus negative, C, negative plus negative, D, negative minus negative, E, negative minus positive, F, negative plus positive. Question number 9. This string has a total of 100 tokens arranged in a particular pattern. What is the value of the string? Here we have a picture of the string with 3 green plus tokens, 2 red minus tokens, 3 green plus tokens, 2 red minus tokens, 3 green plus tokens, and 2 red minus tokens. 10.5. A pinch of history. Like general fractions, general integers, including 0 and the negative numbers, were first conceived of and used in Asia thousands of years ago, before they eventually spread across the world in more modern times. The first known instances of the use of negative numbers occurred in the context of accounting. In one of China's most important mathematical works, the 9 chapters on mathematical art, Zhuang Suanshu, which was completed by the 1st or 2nd century CE, positive and negative numbers were represented using red and black rods, much like the way we represented them using red and black tokens. Page number 267. There was a strong culture of accountancy also in India in ancient times. The concept of credit and debit was written about extensively by Kautilya in his Arthashastra c. 300 BCE, including the recognition that an account balance could be negative. The explicit use of negative numbers in the context of accounting is seen in a number of ancient Indian works, including in the Bakshali manuscript from around the year 300 CE, where a negative number was written using a special symbol placed after the number rather than before the number as we do today. The first general treatment of positive numbers, negative numbers, and 0, all on an equal footing as equally valid numbers on which one can perform the basic operations of addition, subtraction, multiplication, and even division, was given by Brahmaputra in his Brahmasputa Siddhant in the year 628 CE. Brahmagupta gave clear and explicit rules for operations on all numbers, positive, negative, and zero, that essentially formed the modern way of understanding these numbers that we still use today. Some of Brahmagupta's key rules for addition and subtraction of positive numbers, negative numbers, and zero are given here. Brahmagupta's rules for addition, Brahmasputa Siddhanta 18.30, 628 CE. First, the sum of two positives is positive. Example, 2 plus 3 is equal to 5. Second, the sum of two negatives is negative. To add two negatives, add the numbers without the signs and then place a minus sign to obtain the result. Example, within brackets minus 2 plus within brackets minus 3 is equal to minus 5. Third, to add a positive number and a negative number, subtract the smaller number without the sign from the greater number without the sign and place the sign of the greater number to obtain the result. Example, minus 5 plus 3 is equal to minus 2. 2 plus within brackets minus 3 is equal to minus 1. And minus 3 plus 5 is equal to 2. Fourth, the sum of a number and its inverse is 0. Example, 2 plus within brackets minus 2 is equal to 0. Fifth, the sum of any number and 0 is the same number. Example, minus 2 plus 0 is equal to minus 2 and 0 plus 0 is equal to 0. Page number 268. Brahmagupta's rules for subtraction. Brahmasputa Siddhanta 18.31 to 18.32. First, if a smaller positive is subtracted from a larger positive, the result is positive. Example, 3 minus 2 is equal to 1. Second, if a larger positive is subtracted from a smaller positive, the result is negative. Example, 2 minus 3 is equal to minus 1. Third, subtracting a negative number is the same as adding the corresponding positive number. Example, 2 minus within brackets minus 3 is equal to 2 plus 3. Fourth, subtracting a number from itself gives 0. Example, 2 minus 2 is equal to 0 and minus 2 minus within brackets minus 2 is equal to 0. Fifth, subtracting 0 from a number gives the same number. Example, minus 2 minus 0 is equal to minus 2 and 0 minus 0 is equal to 0. Subtracting a number from 0 gives the number's inverse. Example, 0 minus within brackets minus 2 is equal to 2. Once you understand Brahmagupta's rules, you can do addition and subtraction with any numbers whatsoever, positive, negative, and 0. Figure it out. Question number 1. Can you explain each of Brahmagupta's rules in terms of Bela's building of fun or in terms of a number line? Question number 2. Give your own examples of each rule. Brahmagupta was the first to describe 0 as a number on an equal footing with positive numbers as well as with negative numbers, and the first to give explicit rules for performing arithmetic operations on all such numbers, positive, negative, and 0, forming what is now called a ring. It would change the way the world does mathematics. However, it took many centuries for the rest of the world to adopt 0 and negative numbers as numbers. These numbers were transmitted to, accepted by, and further studied by the Arab world by the 9th century before making their way to Europe by the 13th century. Page number 269. Surprisingly, negative numbers were still not accepted by many European mathematicians even in the 18th century. Laraze Carnot, a French mathematician, in the 18th century called negative numbers absurd. But over time, zero as well as negative numbers proved to be indispensable in global mathematics and science and are now considered to be critical numbers on an equal footing with and as important as positive numbers, just as Brahmagupta had recommended and explicitly described way back in the year 628 CE. This abstraction of arithmetic rules on all numbers paved the way for the modern development of algebra, which we will learn about in future classes. Summary: there are numbers that are less than 0. They are written with a minus sign in front of them. Example, -2, and are called negative numbers. They lie on the left of 0 on the number line. The numbers -4, -3, -2, -1, 0, 1, 2, 3, 4, and so on are called integers. The numbers 1, 2, 3, and 4, etc. are called positive integers, and the numbers -4, -3, -2, -1 are called negative integers. 0 is neither positive nor negative. Every given number has another number associated to it, which when added to the given number gives 0. This is called the additive inverse of the number. For example, the additive inverse of 7 is -7, and additive inverse of -543 is 543. Addition can be interpreted as starting position plus movement is equal to target position. Addition can also be interpreted as the combination of movements or increase or decrease. Movement 1 plus movement 2 is equal to total movement. Subtraction can be interpreted as target position minus starting position is equal to movement. Page number 270. In general, we can add two numbers by following Brahmagupta's rules for addition. A. If both numbers are positive, add the numbers and the result is a positive number. Example, 2 plus 3 is equal to 5. B. If both numbers are negative, add the numbers without the signs and then place a minus sign to obtain the result. Within brackets -2 plus within brackets -3 is equal to -5. C. If one number is positive and the other is negative, subtract the smaller number without the sign from the greater number without the sign and place the sign of the greater number to obtain the result. Example, -5 plus 3 is equal to -2. D. A number plus its additive inverse is 0. Example, 2 plus within brackets -2 is equal to 0. E. A number plus 0 gives back the same number. Example, -2 plus 0 is equal to -2. We can subtract two integers by converting the problem into an addition problem and then following the rules of addition. Subtraction of an integer is the same as the addition of its additive inverse. Integers can be compared as -3 less than -2 less than -1 less than 0 less than 1 less than 2 less than 3 and so on. Smaller numbers are to the left of larger numbers on the number line. We can give meaning to positive and negative numbers by interpreting them as credits and debits. We can also interpret positive numbers as distances above a reference point like the ground level. Similarly, negative numbers can be interpreted as distances below the ground level. When measuring temperatures in degrees Celsius, positive temperatures are those above the freezing point of water, and negative temperatures are those below the freezing point of water. Chapter 2 ends here. Page number 271. Integers, snakes and ladders. We have rules here to play the game Snakes and Ladders with a picture of the game given on this page. The rules are: first, this is a two-player game. Each player has one pawn. Both players start at 0. Players can reach either -50 or +50 to win, but need not decide or fix this before or during play. Second, each player rolls 2 dice at a time. One dice has numbers from +1 to +6, and the other dice has numbers from -1 to -6. Third, after each roll of the 2 dice, the player can add or subtract them in any order and then move the steps that indicate the result. A positive result means moving towards +50, and a negative result means moving towards -50.
Ganit Prakash, you were just listening to this audio book, Textbook of Mathematics for Grade 6. Narration Swarnlata. Academic Coordinator Dr. Prakash Vadigar. Technical Coordination Bati Langlingdo. Sound Recordist Vikas Sangwan. Assistance in Production Kusum Lata. Directed and produced by Vimlesh Chaudhary. This audiobook is presented to you by CIET NCERT, New Delhi, India.